Welcome to the 2008 Drilling Fluid Hall of Fame, sponsored by the American Association of Drilling Engineers. The Hall of Fame has two goals. The first is to recognize key individuals who have contributed to the advancement of our understanding and knowledge of drilling and completion fluids, and to share their accomplishments with the rest of the drilling industry in order that they are not forgotten. The secondary goal is to elevate our image as an important part of the oil and gas industry by highlighting the contributions of our men and women. In 2006, we recognized George R. Doc Gray, Leon H. Robinson, Tommy C. Munshine, Martin E. Chenevert, Walter F. Rogers, Don J. Weintraub, Billy G. Chesser, and J.P. Simpson. Tonight, the class of 2008, we recognize Kurt G. Hamill, Ronald K. Clark, A.C. Charles Perricone, Robert L. Garrett, William C. Goins Jr., and Henry C. H. Darley. Now, this is probably somebody that most of you have not heard of, but this is Kurt Hamill. And Curtis Hamill is being recognized for his decision to use mud from a nearby pond to drill through some difficult sand strata near Spindletop at Beaumont. This is the first recorded history of the use of the drilling mud. The well could not be successfully drilled without the application of a mud, and it brought in one of the most important wells in the history of the world. That was Spindletop, and it came in at 100,000 barrels of oil per day. Within 3 months, this well and a few offsets had produced more oil than had ever been produced in the world up to that point in time. Ronald K. Clark is being recognized for his significant contributions in mud chemistry, mud shale interactions, mud environmental impact, mud rheology and hydraulics. He is best known perhaps for his work to develop the PHPA KCl muds for drilling water-sensitive shales and field studies on surge, swab, and circulating pressures. Charles Perricone holds over 20 U.S. patents on drilling fluid products and chemical processes. In his research and development, his primary interests and focus were to provide high-performance products and improved mud chemistry to extend water-based muds, particularly lignosulfonate muds, to high bottom hole temperatures approaching 400 degrees Fahrenheit. Products included a patented rheological stabilizer and filtration control copolymers, which were commercially successful in treating wells with bottom hole temperatures at or above 400 degrees Fahrenheit. Other accomplishments include the use of zinc compounds for the treatment of hydrogen sulfide, and design and use of the first portable mud kit and pilot test kits. So Bob L. Garrett is being recognized for his significant contribution in mud chemistry and the effects of downhole temperatures to 400 degrees Fahrenheit and pressures to 20,000 psi on oil mud flow properties. He is best known for his study of two common acidic gases, hydrogen sulfide and carbon dioxide, and the effect they have on water-based and oil-based muds. From his research came an entirely new mud analysis concept. Two tests, the Garrett gas train sulfide test and the Garrett gas train carbonate test, are now both standard API tests. William C. Dub Goins Jr. His personal accomplishments are almost too numerous to list. In 1965, he published the first book on blowout preventions. He has been instrumental in drilling fluids. We have the patented procedure for lost circulation. That's a diesel oil bentonite squeeze that Doug brought to life and patented, that has helped many an oil and gas company solve a lost circulation problem. Within the drilling community, the late Henry C. H. Darley is perhaps best known as co-authors of the 4th and 5th editions of the Drilling Fluids textbook that has become the standard in our industry, the composition and properties of drilling and completion fluids. Mr. Darley obtained a B.S. degree in petroleum engineering from Birmingham University, after which he joined Shell Development Company in Houston. During his career with Shell, he extended the use of scientific principles and tools to the characterization and development of drilling fluids, which resulted in the publication of seminal papers on wellbore stability, productivity impairment, the effect of solids, especially clays, on mud properties, and chemical kinetics of clay-polymer interactions. After 25 years of research, researching drilling fluids, he retired and worked as a consultant. Accepting for Henry is his wife of 57 years, Nancy, his son Merrick, and his wife Lorraine. Hall of Famers. We have the 2006 class here with the 2008 class. We're doing a Great Men of Drilling Fluids historical tape, which we hope to put together, and it's the thoughts and feelings of these individuals, their contributions that they made to the industry.
You can read books, you can read papers, but you really have to get in the lab and work with fluids. You have to go to the rig to see how they're used and to develop an understanding of what this business is all about.
There's some black art to it, or at least some intuition and some hunches that people sort of develop, I think, from their experience. You know, after you've been in it a while, there's some things, I guess, that kind of gets into your blood and your bones, and you kind of feel a certain way, but that's not the major part of it. The major part of it is actually a strong understanding of the technology and the science behind it.
We don't do a good job of advertising to the man on the street about what we really do in our industry, in the oil and gas industry. We do a very poor job. We're doing things today underneath the earth, just as important and as technology driven as putting a man on the moon with NASA.
Interestingly enough, he always wanted to be a writer, even when he was young. And one of his plans when he retired was to write, and he actually wrote a fairy tale, which is, I think, is about his first attempt. Certainly the first attempt he showed me, and I don't think it was publishable. And so I think he found his true calling when he wrote about what he really knew about, and that was the book, and he was very detailed in that book. Doc Gray, I got the impression, told the big story, and he filled in the details of the story in the detailed chapters.
The thing I remember most, I guess, is that I finished up what I was doing about midnight and drove into Kermit in a blinding snowstorm. And when I got to the house, I undressed, turned back the covers, sat on the side of the bed, and the telephone rang. And I picked it up, and this guy said, "Are you Gus Mud Engineer?" And I said, "Yes." And he said, "Well, I bet you wish to hell you weren't."
I grew up in California, so I went to school at the University of California, Riverside. Got bachelor's and doctorate degrees in chemistry from there. Postdoc for a year at Cornell. Went to work for Shell Development in Houston. Was there for 29 years. About 26 of that was in drilling fluids. Retired in September of '96 and moved to Montana.
I was pretty fortunate in 1957 to come out of Texas Tech with a degree in chemistry, and particularly in emission spectroscopy. And they needed someone at Humble Production Research Company to take over a project because one of the guys was leaving. And so I moved right in from work I was doing at Texas Tech on emission spectroscopy right into doing trace elements in subsurface waters and samples like that, which was geochemistry. Stayed there 5 years, enjoyed it. Went into natural gas processing and did some supersonic flow studies for about another 6 years. Went into a 2-year stint in the reservoir division looking at enhanced oil recovery. And one day Leon Robinson walked into my lab where I was doing bottle tests, and he said, "Why don't you go and see Joe Heiliger down in the drilling fluids section, and I think they have an opening down there, and you might like doing that better."
I was kind of attracted towards the medicine, but I didn't figure I could finance that much education. So I took chem engineering at Texas A&M instead.
Yes, we married in 1942 when he graduated from A&M, and he went into the military, and he went overseas for during World War II. And then when he came back, he went to work for Gulf.
In 1952, I graduated from the University of Texas with a master's degree in ceramic engineering. I knew Mr. Donald Weintrigg, who was also a ceramic engineer, and I knew at that time he was working for a mud company called Baroid. And as a result, I contacted him and asked him that I was looking for a job. This was, the timing of it was not very good, because at that time we were in war with Korea, and I was coming out of school with a deferred classification as a student, and I was subject to the draft, and I thought that possibly if I could get into an essential industry that was producing oil and gas for the war effort, that maybe I could prolong my stay as a civilian before I went into the Army.
Because it was his uncles who got my husband interested in petroleum engineering. And as he said, he was born in Ireland, educated in England, and lived the rest of his life abroad.
I grew up in the East Texas oil field, and when I got out of the Army, I applied for a job with Gulf in Fort Worth, and they said they would give me credit for roustabout and pumping, but they wanted somebody to know that knew something about drilling as an engineer, because they didn't have any. So I roughnecked for a while, and then I became a mud engineer for Gulf in 1946.
How I got in the mud business. When I went to work for Shell Development, I initially worked in enhanced oil recovery and dissolving sulfur in compressed hydrogen sulfide gas. A lovely project. It stunk to high heavens. I probably couldn't do that kind of work today. They wouldn't allow it in the lab. Then I went to looking at solubility of polymers and compressed CO2, again for enhanced oil recovery, trying to improve the mobility of CO2 by increasing the viscosity to cut down fingering. As part of that project, I got involved with capillary viscometry, looking at the viscosity of these things. Well, Shell decided, since I was doing viscosity, I knew something about rheology, which I really didn't, and they needed somebody to come into the drilling fluids group. So one day, I think it was March of 1971, as I recall, I got called into the manager's office, and he said, "You're being transferred into the drilling fluids group." I had no clue what drilling fluids were, had never really heard of drilling fluids, even though the group was right there in the same facility on Bel Air Boulevard in Houston. And so all of a sudden I became a drilling fluids guy.
I think one of the problems that I had as a young mud engineer was that I always considered that the mud engineer was not given the respect that that person needed in the responsibility of running the mud on that particular location or rig. I think too often the mud engineer has been taken for granted.
I worked there until about the middle of 47, and then Gulf decided to transfer me back to Houston to the chemical laboratory, and so I never made it as a petroleum engineer, but which was the original plan. Anyway, when I got to Houston, I was in charge of evaluating mud materials, and mud chemistry in general.
Wound up in the basement of the what was then Exxon Production Research Company with a monster of a piece of machinery that had been built but didn't work. It was a capillary viscometer for high pressure, high temperature oil muds. There wasn't much I could do, but I did get interested in oil mud settling as to what you could do to prevent it and how you could study it and how you could measure it. So I did a little bit of the rheology early on, high temperature like 400 degrees, 20,000 psi, which was pretty new at that time. This was 1968.
Yeah, after that, I took early retirement and started in consulting business with T.B. O'Brien. Was in Midland at the time, and later Jay Simpson joined us. And we had 20 some odd years of consulting work.
Okay. He failed to tell you how much traveling he had to do with this job. I was the wife that stayed home and took care of the kids, and he has been all over the world. And I can't tell you all of the places, but he traveled constantly while my children were young. And we've been married 65 years.
I worked for Baroid approximately 5.5 years. After the 1 year time frame as a utility mud engineer, I was then assigned a permanent territory with my headquarters being in Edna, Texas. And my responsibility was 3 or 4 counties around Edna, including Calhoun County, El Campo. I'm not sure what the name of that county is, but and I worked as a mud engineer responsible for those 4 counties and all the wells that were being drilled by Baroid in those 4 counties.
Yes, I moved in 1957 from Texas Tech, like I said, and 5 years plus 6 years plus 2 years, that's like 13 years, I guess, I was in something besides drilling fluids. But then after that, I was in drilling and drilling fluids for another 29 years, roughly, I think it is. And it was all under Exxon or affiliates, but I never had to transfer out into another city. I always stayed in Houston.
During the period I was with Gulf, they transferred me to Gulf Research and Development Company in Pittsburgh. I spent 2.5 years there and then came back in 1960.
And then after I left Baroid, I went to work for a company that was just an upstart mud company called Millwhite Mud Sales Company.
But anyway, it's been just an absolute wonderful career. I mean, you couldn't ask for anything better, in my opinion. It's just been a terrific way to spend a few years. And of course, after I got through with Humble or Exxon never was ExxonMobil in my case, but I went into the consulting business, and I did almost as many years after Exxon in consulting, and that was probably as gratifying as anything I've ever done.
Millwhite Mud Sales Company eventually became known as Millchem. And then from Millchem it became part of Baker Hughes in 1980, and later on Millchem became known as Mill Park, and then it became known as Mill Park Drilling Fluids after it merged with Hughes Tool Company in 1987. And later on in the 90s, it became known as Baker Hughes Intech.
One of the more memorable things was Tommy Monshine talking about oil muds and shale stability and the need to adjust the calcium chloride content of the oil mud to harden the shale, or at least not to let it disintegrate, for wellbore stability. And one of his more memorable, amongst other things, demonstrations was to put balls of clay in invert oil emulsion muds with different levels of calcium chloride in the internal phase. And then he would take them out and show that If it was a freshwater internal phase, the clay was really soft. If it was saturated, it was hard, you know, and kind of how that, the higher the calcium chloride content, the firmer the shale was. And what he would do that made this very memorable is he would go up to the blackboard and he would draw a picture of this very ugly woman who was Maggie Macabar. He worked for Baroid. Maggie Macabar. Macabar was the main competitor. And then he would stand at the back of the room and he would throw clay balls at Maggie Macabar. And the soft one would stick right in her face and just run down the board. That was really memorable. I still have that picture in my mind.
When I first started with Baroid, I went through the mud school. The mud school also was taught by another Hall of Famer, Mr. J. Simpson. And after mud school, I went into, at that particular time, they did not want to assign me to a permanent area or territory. They put me into a utility pool as a utility mud engineer.
And so I decided, well, settling is really a problem with these oil muds. And down in Sarita, South Texas, they had really deep hot wells, 20,000 psi bottom hole pressure, hot with H2S in it. And they had packed those wells with oil mud, and guess what? They had settled the solids out. And so they were trying to rework wells they were trying to blow out. So I started doing studies of oil mud suspension and settling and prevention of settling, and built a device that was big, long, 6 foot high, 6 foot tall thing that would allow you to study settling oil muds. So that was my first project, looking at oil muds, settling primarily. We helped to design some of the Pracker fluids that were used in Sarita.
T.B. O'Brien had come through the mud school I was teaching, and then worked for Gulf for quite a while, and left and went with a road in oil and gas, and consulting business. And he came in one day and said, you can retire anytime you want to. And he said, I can guarantee your salary and more. He said, let's start a consulting company. And I thought about that a little while, and I said, well, I can't think of anything to object to. So that's when we started. And I guess it was a couple of years later that Jay joined us. We knew him already.
And then we had the Mongour Wildcat well in Mississippi, which was kind of an offset to 2 or 3 blowouts that they had had early on back in the 60s and 70s. So we had to design oil muds for that. So I got pretty hip deep in oil muds pretty quickly, all kind of starting from just wondering about settling oil muds and how to prevent it. So I moved on, and oil muds became interesting, but I went on to other things, and water mud chemistry became of importance, and I got into that. And then I did tech service work and training and teaching for Exxon, different parts of the world. Every one of them was a challenge.
Well, in that era, believe it or not, most of the rigs at that time were steam driven. And I don't know if many young engineers know what a steam driven rig is, but in some ways it's from a nostalgia point of view, I liked them. I like the generation of the steam and the mud pumps, which operated off the steam and so forth.
Made quite a change. I mean, we would never early on have used an oil-based mud that would have cost more than, $50 a barrel. And all of a sudden, here were ester-based drilling fluids that were costing hundreds of dollars a barrel. So there was a real shift in people's acceptance of those much higher cost fluids.
And the guy had come in and brought him a piece of shale. Now, this was a preserved sample of like a 4-inch core, And the way they preserve them is they wrap wire around the core, they dip them in paraffin, and then they pull them out, and after the paraffin cools, they wrap them in aluminum foil, and that's a preserved core. So Martin had this in his aluminum suitcase going home through the Maracaibo airport. So here's this piece of rock about 8 or 10 inches long, about 3 or 4 inches in diameter or better, with 2 wires sticking out of it.
Well, we were out in the jungle, definitely the jungle. The river ran down, cutting us off in the town of Barrancapameja, and we were the other side, and you could only get over to the town if the weather was dry, because the roads were made of mud. And he was away quite a lot because he'd visit different oil fields all over Colombia, and especially down south in the plains. And then he'd come home, and then he wasn't allotted a car, so he managed to find an old car which no one could get to drive, and as we lived at the bottom of a hill, he'd park it halfway up so that he'd get it to crank over, you see, and coming down the hill, and then he could but he couldn't stop till he got to work because the thing was getting it to work again.
And I've had people talk about mud chemistry in lectures. I had one guy in the back of a lecture in Norway one time at the end of my discussion of pH and alkalinity and water chemistry and all, and he stood up in the back and he says, "That's the biggest bunch of horse shit I ever heard."
Then when they invaded, or pushed Saddam Hussein back, we ended up with 18 people again who were coordinators for blowout control. And Larry Flack was our chief drilling engineer at the time.
Got full-fledged in 1968 onward. I got really eye-opener, I guess, in terms of, you know, the importance of really watching out what we used in the mud. And it wasn't just what it cost or anything or how it performed. It just became very important as to how it affected the surroundings, you know, the environment. So yeah, that was probably the biggest change I saw. And it's moved on through the years, and we had people who really took on muds as an environmental challenge. And I might mention Bob Ayers was one of the guys in our company, in Exxon, who I think led the forefront in a lot of this, keeping things clean, cleaning up our act, getting muds more acceptable. Of course, there's a bunch of others that worked on that too, but that really made a change.
And that was the opportunity that I had to test the first Invramol for baroid. It was a dry processed Invramol containing crude tall oil and lime hydrate. And we had just hired a new Hall of Famer by the name of Tom Munshine, and he and I went out to this rig, and this rig was located in the sand dunes of Monahans, Texas. And the purpose of our trip was to test this dry processed Invramol made from this crude tall oil and lime hydrate, trying to agitate all this settled dry powdered Invramol from the bottom of the tank so that I could disperse it. In the meantime, Tom Munshine was on the other end of the tank looking to see what I was doing. And lo and behold, unfortunately, one of the braces that was still exposed in the tank, it was a cross brace of metal supporting the walls of the tank. I hit with the mud gun, and the mud hit the brace and it ricocheted, And as he was looking in the bottom of into the tank, I completely sprayed him with oil, this hot oil, all over his face and body, and he was just dripping with oil. And I felt so bad because I had really given him a baptism of mud at that time, his first trip out to an oil well. But he took it very good-naturedly, and before it was all said and done, he was all over that rig, including the monkey board, which he had difficulty getting off of.
There was a rebellion in Bogota, in Colombia, and we had been told that we were going to go to Houston. And of course, our passports and everything had been sent up to Bogota. And we were worried that they may have been destroyed in all the fighting which was going on at the time. Anyhow, we got up there and stayed in a motel, and after a day or two, there was guards outside our door, at least preventing us from going down the corridor. And we found that one of the head people in the government there was was in the room next to ours. So every time we went up to our place, we kind of walked through drawn swords. You know.
I think one of the neat things about drilling fluids from a research standpoint is you could go in the lab and you could dink around and you can come up with something and you can go try it and you find out quickly whether it works or it doesn't work.
Back to another war story again, this I think was in Malaysia. There was an old man who had been on the rigs of Oklahoma and Texas and now working in high dollar offshore areas. He still wanted to test mud with a shovel. And the story was that back on the land rigs, the first thing you moved from one location to the other was this old guy's shovel, and put it right in front of his door of his trailer house, because he would take that shovel and he would let the mud run off the edge of that shovel and he could tell how good it was.
Yes, he wrote it at home because he had to keep all the different information about him. In fact, I wanted to go to my home for a holiday, and he says, no, we can't go because I can't take all this information with me that I have, and I must stay home and write. And that went on for many years, that he had to write his book. That kept him occupied a long time, and it was good for him because he liked it. He liked doing that work and getting information from different people and looking out for things to write about.
And went into a lab. I knew nothing about drilling fluids. Luckily, I had a very good lab technician by the name of Dick Bonner, who taught me drilling fluids initially, how to test them, what the equipment was. I didn't know what any of the numbers meant.
Mentors, I had probably more than one, but of course Leon Robinson was one of the ones, and he came to me and said, hey, why don't you come and work in drilling fluids? He was one of the early ones, and of course there were others. Diddy O'Brien was a supervisor of mine early on, and he was very encouraging. Nearly all of the people I had to work under and with were considered mentors. If you look at some of the people like Jay Simpson, for instance, and guys like him, they were, leaders in my mind in terms of, following them as examples of doing things. Don Weintraub would certainly be one.
We hired Bill Chesser in approximately 1961 from his previous job, Sun Oil Company in Beaumont, Texas. And we immediately assigned him the task of coming up with an oil-based emulsion fluid for our company at that time. I think that company was called Mill White Mud Sales Company. And we put him on that project, and eventually he became a lab manager in the technical services group, and I became manager of R&D. And so we worked kind of hand in glove, he handling the practical everyday problems, and I'm trying to handle the future problems for the company.
I had the opportunity to go to a customer mud school at Baroid, and I think it was a week-long school. I met some of the giants of the industry. You know, Jay Simpson was there, Tommy Monshine was there. These guys were teachers in this school. Norm Shirley, I can't remember if Don Weintritt was there or not in the teaching, but he was at Baroid. And so I started learning a little more about drilling fluids and how they were formulated, what the compositions were, what the testing, what the numbers meant, and also about drilling.
I know over my career, I would have never gotten very far had it not been for the cooperation of all the friends and colleagues that I've associated with. They have just been an asset you can't even measure.
We had a device we call a triaxial tester, where you take a shale briquette, we call it 2 inches in diameter, about an inch thick, that we would form in I think in a press of about 10,000 psi pressure. Actually, Slim Darley, who's one of the honorees, developed that device. And he had a unit in his laboratory. Slim was at Shell when I came into the drilling fluids group in the early 71, and he retired later that year. And I didn't have that much interaction with him about mud because I wasn't smart enough, didn't know enough about mud to even ask questions. And he was kind of this mythical God type figure almost to most people in the mud business.
Well, this is a very emotional topic right here for me, because I had for all those years a wife, Daphne, who was right there. She was with me. And she passed away about 7 years ago, and I really miss her, but she was really something. And my son worked for IMCO, I think back in the summer of his junior year in high school, and he worked for Scott Stewart and Mario Zamora, who's asking me these questions, and some others there at the IMCO lab. And I think Larry, and that's one summer, Roger Blyer was there too. I think he was actually the head of that group. But with Scott and Mario and Roy Lofton and all the others, Larry learned a lot that summer, and my son. And so he, I think, got a real appreciation for that kind of work and for laboratory work. He wound up becoming a veterinarian, and now is in biology in Victoria College. So all the family is just really a big asset to you if you've got a supportive family, and I did.
The hardest thing is leaving your friends behind when you move like that. You make friends all over the place, of course, which is wonderful. And then even just moving, like we've moved now from Houston to Plano, it's the friends that you're sorry to leave behind.
My personal opinion was that I felt like the mud engineer was a very important part of the total drilling operation. And that was one reason why eventually I got out of mud engineering and got into R&D, because I felt like I could contribute more in R&D than at that time that I was contributing to mud engineering.
Well, there were temptations to go into other companies, not ever a temptation to move out of the oil industry, because to me that was the place to be. I didn't near have the crystal ball that I might have, because you see today it's really the industry to be in. But I always wanted to be in the oil industry, and working for Humble Oil in those 1950s was almost the top of the heap. You just weren't going to find a company much better than that to work for. And when they offered me the job, I certainly jumped at it. I had a chance to go work on rocket fuels in New Jersey, but I turned that one down. I didn't want to blow myself up.
Besides, the people were just great. The people were fun, and it's hard to beat that when you have a good group of folks. And I think one of the other things that really, in thinking back on it, that I really liked was that once I got to know people, and the API really helped me get to know the people in the other oil companies and mud companies, was that if I had a problem or I had a question, I could call anybody that I thought had the answer, and they would help.
The thing that stands out most in my mind is when I first met Merrick and we went to Houston to meet his parents, and Merrick had told Granddad, that's what I always called him, about our trip in Kentucky when the snow had come down and I got out of the car to help fix Merrick's car. And so later Merrick told me that Granddad said, any girl that's going to get out of a car in a snowstorm and help is a keeper. So that's what I always knew from the start.
He did separate his family and work, but always respected him, very intelligent. He had an awful lot of common sense.
I think today the mud industry is faced with a lot of new challenges. I think we're beginning to see a depletion of a lot of the resources that went into drilling muds. By that I mean barite for one, bentonite, gilsonite. There are a lot of natural resources. We spent sulfite liquor that went into the lignosulfonates, the lignites. There are a lot of resources that are slowly being depleted that will have to be substituted by new products.
It's a good business to be in regardless, because it's challenging, it's interesting, there's a lot of new things going on, and you can just find all kind of things to do. But the people who are in this area, they recognize that, and they're an interesting bunch of people. They're a talented group of people. They have lots of interdisciplinary skills. Some of them know a lot of stuff about a lot of things. And they all seem to have a personality that's different. There's no two alike, seems like. And as I look at some of the people, and I met them here today, here at this meeting, at this Hall of Fame award, it's just amazing as to how talented these people are. And even after a few years have passed, you see them when they're in their 70s and even beyond, there's still light in their eyes, they're still interested in it. And they are just, I think, a wholesome bunch of people.
Since Mom just got a check for 99 books. We kind of use it as a monitor of the oil industry. The oil industry is looking up, the books are selling, I guess because people are being trained in the industry to do the fluid engineering.
Engineers are pretty dedicated. I think it was Gwendolyn Rice that said, take time to smell the roses, and because years can pass a whole lot faster than you think they would.
Tell a young person that there's a tremendous opportunity in the mud industry. But they have to be creative and innovative in their thoughts and ideas.
I mean, it was chemistry, it was physics, it was biology, it was geology. It just involved so many different disciplines, so there was always something new and different to learn.
If you don't try it, you're not ever going to know what this industry is really like. But if you do try it, if you can get into it properly, I think most people with a technical background will find it's as challenges as anything they want to get into. And it'll be more satisfying probably than anything else they can find to do, because it's a mixture of nearly everything that you might want to try. It's outdoor life, it's chemistry, it's innovation, it's whatever you want to make of it. So I think it's a wonderful opportunity.
I recommend to people, the young people that I know in Livingston, get into petroleum engineering. There's a great need for good folks, and you won't regret it. You're compensated well, plus you have a wealth of good, have a wealth of good friends. And I don't know, you can't do any better than that as far as I'm concerned.
So I can see a lot of new challenges facing us, and coming up with new resources to supplement those that are slowly but surely being depleted. That's one thing. The other thing that I see is that I really believe that we are still on the cutting edge of trying to come up with improved fluids that are truly green fluids.
There's something about the oil business that's kind of infectious. And I've known people that have gotten out of it and have come back because they like the activity.
I think the challenge partly is for people to understand what's available right now. I mean, if I were a youngster starting off right now to try to learn something about drilling muds, I think I would be totally, I don't know, baffled by what all there is to learn. I don't know how anyone is going to pick this up in a short period of time and become a true expert, wide range, broad spectrum expert in drilling fluid technology today, because there's just a lot out there to learn.
So I think there's a tremendous challenge facing people coming up the ranks, and I hope that we will have those kind of people that can fill the voids that we will slowly but surely be leaving.